Alright, so I know I said I wasn't gonna actually get this printed until I got a 3D printer, but Shapeways offered this new material, PLA, which ironically, for most people familiar with 3D printing, it's actually an old material that a lot of the standard off-the-shelf 3D printers have been using for a really long time. It's cool because it's made out of corn starch, I think, and it's like a quote-unquote green plastic. So yeah, it's cheaper than the default material, and so I printed out one of my quick connects, which I just designed like last week, I think. So I submitted the design and placed the order on the 3rd of this month, and the parts came on the 7th. So that was pretty awesome. Like basically 5 days is all it took from submitting the design to actually getting the parts. Still a little expensive, but that's mainly because I designed these to be so heavy duty and sturdy that it requires a lot more material than you probably actually would need for this design. In retrospect, it seems kind of silly to me now how overbuilt I made these, but that's one of the coolest things about 3D printing is your design in your CAD program, whatever, is so different than the one you actually get, even though it's the same scale. When you're holding it in your hand, like, and you're trying out the parts, you see so much more than just what you can see even with advanced simulations on in your 3D program of choice. So I'm gonna just talk briefly about what worked and what didn't work. And okay, first thing, if you're going to be printing in PLA, do not go with 0 tolerances. Now here's the thing, like the default plastic material, I think it's called like strong and flexible or something, that normally you get if you order a model through like Shapeways. 0 tolerances are fine with that stuff. I mean, yeah, it's still a really tight fit a lot of the times, but it's totally doable. But with PLA, I actually found that the tolerances were like way off for a 0 tolerance fitting, which is what I designed. Like this would have worked with the default plastic, but I actually had to shave off or sand off 0.5 millimeter to 1 millimeter of material on pretty much every contactable crucial surface. And that was another cool thing I learned when I was trying to get this to fit the way it's supposed to, and that was that there are areas that I didn't really realize there were friction problems with until I started scraping the parts together and getting them to fit. So once I noticed those, like right here, like on my next version of the model, I'm going to chamfer this edge, or maybe just round it off so that it actually has smoother action. But I would say 1 millimeter of tolerance is very reasonable for PLA because it's kind of a rough material. In general, I say this it's a lovely texture, kind of silky, slippery, very strong. Like, oh, you would not believe how I was manhandling these pieces to get them together, and incredibly durable and strong. Pretty much everything works as it was designed, except for, like I said, that tolerance problem. This, since it's a hermaphroditic interface, I sort of had double the tolerance problem because each surface is symmetrical, so it's like if I were to take off, you know, 0.5 millimeter on every one of these contact points, then I would get the full millimeter of tolerance. So actually that worked in my favor, and I actually had to take off less material than I would have normally. But okay, successes. Sorry, I'm getting off topic. Okay, first of all, this little indentation here, the circular indentation, is designed for these standard poly washers. A lot of quick connects use proprietary O-rings or, you know, special gaskets. These are just off-the-shelf poly washers, and they have these little nibs on them that are used. Normally they stick in the threads of your like hose threaded female socket, and that keeps them in place. And obviously you don't want to be losing your washers all the time when you're using quick connects, so I put like a little millimeter lip here that works. Like, I was just so pleased with this. Here, I'll pop in the washer and you'll see how it fits. Like, pretty much an absolutely perfect fit, and since I measured these really carefully with my calipers, I was basically expecting a perfect fit, but it was still quite pleasing to see just how precise it was. And also, this is kind of hard to see in profile, but the depth of this little socket here for the washer is actually designed to so that the washer protrudes about 0.5 millimeter, and that also worked. That's really important for this design because you have a washer on both sides, and they have to basically create a perfect seal, and so that requires a little bit of protrusion, and that actually was exactly right. So that was like a success for that part of the design. And as you can see, if you look down here, you don't see any O-ring sticking out. So this is like literally, like, you cannot pull out the O-ring. So, and that's crucial because when you have high pressure water flowing out of this thing, it could in theory push and pop the O-ring out of there, or the washer in this case. So that's why I designed this to be completely flush with the washer, so that the water isn't going to pop those washers out of there. Okay, so yeah, this is just how it's supposed to be. There's a little bit of play there, so the leverage action of turning these actually pushes those washers together, creates compression, and you get a watertight seal. So success there. Really hard to get apart because, like I said, those tolerances, even after the sanding and filing and dremeling, is still not perfect. Okay, second success, my hose thread male coupling here, like 1200 polygons. I can't remember exactly what it was, but like I mentioned, this was like a serious problem for me, the getting the specification right and creating the topology that met my incredibly strict quality standards. But this totally nailed it. It's like a totally perfect, exactly what I was after, and no problems whatsoever with the fit on that. That is like rock solid. So yeah, now the only thing left to do to test out this quick connect is to actually hook it up to a hose and make sure that it's watertight. And I gotta tell you, it'd be really disappointing for me if it doesn't, considering how much I've already talked this crap up. So yeah, on Monday I'm gonna go to the garden, gonna bring my camera, gonna test this thing out with 75 psi, which is the actual pressure of the water at the campus that I work on. So yeah, anyway, I'm really excited about this. Do not print out the model that I uploaded because, like I said, the tolerances are off. I mean, don't print it in PLA. You could print it in like regular material if you have like a really expensive 3D printer, but I still honestly wouldn't even bother at this stage because I want to like refine this a bit more. I'm gonna spend some time on that today and hopefully get a perfect version 2.0 for this thing. And let's see, is there anything else I wanted to cover? Just that how cool this is that you can go right or left. I just a triumph for people like me with dyslexia. It's just like I've been wanting a hose connector that could do this for so long, and now I have it. Realistically, I don't think it's completely insane to imagine something like this actually like being adoptable. It's not bad. I mean, I was skeptical when I was designing it that these prongs would be kind of an issue, but I could see this sticking out of like the side of a building, or you know, just being a general garden type thing. So yeah, it's another success, I think, was just the ease of putting the coupling together. Like, that was another thing that I was worried about because of the prong slot type system that I chose. I thought it might be kind of challenging, but no, actually it's not. It's just incredibly easy to slip those in there and give it a twist. When I was breaking this in, I found that like I could put a quarter in between there and twist it to loosen these up, which actually was a huge help. And this little angle right here, I think this is a 12-sided polygon that kind of is crucial to the way the design works. That also worked exactly as I had intended with the prongs. Like, when you're right on the edge there, they actually stick out and you can see it on both sides, and when you close the you make the connection, they pop back in as they were designed to do. So yeah, I haven't made too many things like this so far, industrial design, and I feel like I'm getting a little bit better at it. It's taking some time, but I'm definitely improving, and I'm hoping that eventually I'll be able to just design things like this with like one design and like version 1, and it will just work and it will be done. So I won't have 2 versions, which I think 2 to 3 versions is what I'm up to right now in terms of my competency. It takes me about 2 revisions to get the perfect, you know, iteration. So anyhow, really excited about this, as you might be able to tell, and I probably just locked this together. It was funny, the first time I put it together, it like locked into place, and like literally there was I couldn't even budge it. I was like, oh wow, this is supposed to be a quick connect, and it's like a one-way thing. I didn't think I was gonna get it apart. And PLA, incredible, like incredible strength. Like, yeah, these are pretty thick, these prongs, but man, I was putting so much torque on those. I was worried they were gonna snap right off, but they didn't, and you can just feel it. You can feel the strength in the PLA. It's incredibly tough stuff. And green, biodegradable, whatever. Yeah, I'm just talking and talking and talking. Thanks for watching.